You're watching the Mr. Quality Guy YouTube channel.
Hello everyone, Mr. Quality Guy here, and today we're going to look at the importance of material analysis in manufacturing, and we're going to use the Carl D. Bradley sinking as an example of this. So sit back, relax, and enjoy this simple journey through material analysis. The Carl D. Bradley is a fantastic example of the importance of material analysis. And in order to understand that, let's take a look into the career of the Carl D. Bradley. So, starting as a whole in 1923 and launched in 1927, the SS Carl D. Bradley was 639 in feet, 194.8 meters in length, making it the largest self-loader freighter on the Great Lakes for 22 years. These ships, these freighters of this size and era are just massive. But on April 3rd, 1957, the Carl D. Bradley was involved in a collision with the MV White Rose. Later in May, the Bradley was in dry dock for 7 days for major repairs to her hull. In spring and early November in 1958, the Bradley had 2 groundings. The November incident required repairs. Neither groundings were reported to the U.S. Coast Guard. April 17th, the Bradley underwent annual U.S. Coast Guard inspection and was found to be seaworthy. On October 30th, 1958, the U.S. Coast Guard conducted a safety inspection that included a fire and boat drill. These are important to understand for the simple fact is that this ship, being 639 feet long, is in heavy rough water a lot. But let's look at the fate of the Carl D. Bradley. On November 18th, 1958, carrying a last-minute load, heading back to Gary, Indiana, the ship encountered a November gale storm with winds blowing 60-65 miles an hour, and at 5:35 p.m., the ship was 12 miles southwest of Gull Island when the first mate saw the stern of the vessel sagging. Shortly after, the ship broke up and split in 2. So just imagine being on this massive freighter and the ship snap in half, and that's what happened. Unfortunately, there were only 2 survivors of this incident, and there's many books on this, but we're not looking into the sinking itself. We're looking into other things. So the U.S. Coast Guard tech experts were aware of the notch-sensitive and brittle steel used on ships built prior to 1948. These defects were believed to be the cause of the sinking of the SS Carl D. Bradley and the sister ship, the SS Daniel J. Morrell. Both these ships were built at the same time. They were both operated by the same company, and the Daniel J. Morrell, during towing for scrap in 1966, also broke apart and sank. And this is also believed to be causes of many of the lost freighters and even large passenger ships. It is to believe that the Titanic sank for this similar reason. So after we go through this, we need to understand, okay, U.S. Coast Guard tech support says notch sensitivity and brilliance of steel. Well, what does that necessarily mean? So notch sensitivity. The notch sensitivity of material is the measure of how sensitive material is to notches or geometric discontinuities. Notch sensitivity is influenced by many parameters such as notch geometry. 3 types of notch geometry: V, U, and general shaped notches of various sizes are to be considered. And essentially, this is how the material fractures and tears away. In a freighter, you need it to be, the steel to be malleable, because at 639 feet long and under various loads, you want the ship to flex to a certain point and return. If it was solid, you would have essentially, it would act like a seesaw, which would be very, very bad for especially being loaded as heavy as they are in the centers of them. So we will look at the brittleness of the steel. So generally it is believed that the sulfur content is the cause of the steel being brittle. And if we look at, generally sulfur is an undesirable impurity in steel rather than an alloying element. In amounts exceeding 0.05%, it tends to cause brittleness and reduce weldability. Alloying additions of sulfur in amounts from 0.10 to 0.30 will tend to improve the machinability of steel. Such types may be referred to as resulfurized or free machining. Free machining alloys are not intended for use where welding is required. And then if you look at the bottom left, we have a chart here, and this is steel grade used in boat making, and this is modern, of course. In the early 1920s, they really didn't understand a lot of this stuff. We do now. So if we look at the different grades, the percentage of phosphorus and sulfur stayed very, very stable throughout. And the only difference is the percent of carbon. Now, the more carbon you have, the harder the material is going to be. But at the same time, it also, very hard material also becomes very brittle. Glass is a great example. Glass is extremely hard, but it shatters really, really easy, and that's the brittleness. And so when we look back and understand that, hey, this ship grounded twice, and neither of the ship groundings were reported. And the other ironic thing is, this was the ship's last journey for the season. And after the season was done, it was going to be laid up and have the whole bulkhead replaced. So the whole essentially center section of the ship was going to be replaced. So they had an idea of knowing that, hey, there's something wrong with this ship. Now, whether these groundings should have been reported to the Coast Guard, they probably should have. Because it would have hopefully triggered another inspection, and maybe they would have found something, wrong with the ship. But that gets us into what we can learn from this. So by understanding material analysis is important, as using the proper materials for application is crucial to safety of the product you are making. So when you look at other examples of this, the number one thing is they say the steel is bad. It's a bad steel. Well, the steel wasn't bad. The steel just wasn't proper for the application. As we can see, steels with higher sulfur content, is great for machinability. But for something that is going to be riveted and welded together, not so much. This was not good ship-making steel, but it was still good steel, just not for the process. And understanding using the proper material for the intended design is really, really important, because using improper material could end up in a loss of life, as we saw with the Carl D. Bradley. So that's what we have for today's little history lesson, and tying it into a usable example. Thank you all for watching, and I hope you have a great day. Hey, so thank you for watching this video covering material analysis, and if you're interested in more videos on these topics, comment down below and we'll try to get to them. So just like to thank you all, and have a great day.